Hello everyone, I am Akhil Dev, Senior Chemistry Faculty, Narayana, Hyderabad. Today we will be discussing solutions to memory based questions of 30th Jan JEE main paper afternoon session. Let's start the discussion. First question is maximum number of electrons in n equal to 4 shell. We know that the number of electrons in nth shell is given by the formula 2n square. Put the value of n 2 into 4 square 2 into 16, the number of electrons, maximum number of electrons in the fourth shell comes out to be 32. Hence, the correct answer will be the fourth option. It's very easy, very straightforward question, and this formula we do in junior classes also. So, I think most of you must have marked this correctly. Now, let's move on to the next question. Next question is a question from environmental chemistry. The BOD value of water sample is given as 3 ppm, and based on this we have to identify whether it is a polluted water or a clean water, or concentration of oxygen is very less or none of these. Normally in a sample of clean water the BOD value ranges between 3 to 5 ppm, and as the value is around 3 ppm we will say that the sample of water is a clean water, hence we will mark the second option. It's also an easy question, a straightforward question, provided you know the BOD values as given in the chapter environmental chemistry in the NCERT book. BOD values higher means highly polluted water, BOD values less than 5 ppm normally means clean water. So now let's move to the next question. Now this question is regarding solubility of chlorides in an organic solvent. These chlorides, apart from beryllium, potassium, calcium, magnesium, these are the 4 elements given. Potassium and calcium chlorides are predominantly ionic. They will be very less soluble in organic solvents. Ionic compounds are more soluble in water and polar solvents. Magnesium chloride has some covalent character, but magnesium chloride is also predominantly ionic. Talking about beryllium chloride is a covalent compound, and covalent compounds are found to be soluble in organic solvents. Therefore, which chloride will be most soluble in organic solvent? It must be the beryllium chloride. Beryllium chloride is a covalent compound, will be soluble in organic solvents, hence we will mark the first option. We can also solve this question logically by applying the Fajan's rules. More charge means more covalent character, smaller size means more covalent character. Beryllium plus 2, calcium plus 2, magnesium plus 2. Beryllium, calcium, magnesium have plus 2 charge, potassium has plus 1 charge. More charge is present on beryllium, and beryllium is the smallest of all these. Therefore, beryllium plus 2 will have the maximum covalent character. Beryllium chlorides will be having maximum solubility in the organic solvents. Fine, understood? Now let's move on to the next question. Next question, again an easy question, not very difficult, straightforward question. Order of bond strength of hydrides of group 16, oxygen, sulfur, selenium, tellurium. These are all hydrides of group 16. It's a very straightforward question. Down the group, as the atomic size will increase, the bond with hydrogen becomes weaker. So H2O will have the highest bond strength. From H2O to H2S, H2S to H2SE, H2SE to H2T, bond strength will decrease. The correct order of bond strength will be H2O more than H2S, more than H2SE, more than H2T. As the size of the atom will increase, the bond with hydrogen will become longer and weaker. The strongest bond is hydrogen-oxygen bond, weakest bond is hydrogen-tellurium bond. I hope everybody has marked this correct also. Now let's move to the next question. This is a question from GOC. The order of acidic strength of following compound. These are all phenols and substituted phenols having substituents at para position. We'll compare the acidic strength by the effect of these substituents. OCH3 we know that is a plus M group. Plus M group decreases the acidic strength. NO2 is a minus M group. Minus M group increases the acidic strength. This isopropyl group will have plus I and hyperconjugation, plus H and plus I effect. Plus M will dominate over plus H and plus I. We will say that D is the weakest acid. Plus M and plus H decrease the acidic strength. We will say that C is the strongest acid. Overall order will become C greater than A, greater than B, greater than D. D will be the weakest acid. CABD, which option? Will mark the second option. Fine, understood? So these are all logical questions. If you have done the concepts well, thoroughly, you will be able to solve these questions. Now talking about the next question, it's a question from coordination chemistry from the shapes of complexes CONH3 whole 3 Cl3. It is a complex of type Ma3B3. Ma3B3 type complex can exist in two geometrical isomeric forms. It can exist in the facial form as well as the meridional form. Let me draw the two forms. Cobalt bonded to 3 chlorine and 3 ammonia. It's an octahedral complex. Cobalt bonded to 3 chlorine. All the 3 chlorines may be perpendicular to each other, resulting in chlorine-chlorine bond angles of only 90 degree. And all ammonia will also be perpendicular to each other. This is the facial isomer, also called the cis isomer. So chlorine-chlorine bond angle, chlorine-cobalt, chlorine bond angles are 90 degree here. Another isomer that is possible is the meridional isomer. This is the facial isomer. Another isomer that is possible is the meridional isomer, in which we can have chlorine and chlorine opposite to each other also. And this will be the meridional isomer. And in this meridional isomer, the chlorine-chlorine bond angles may be 180 degree also. So in addition to 90 degree, another possible bond angle for chlorine-cobalt bond is 180 degree. The possible bond angles can be 90 degree or 180 degree. Which answer will mark? Will mark the second option. The Cl-CO-Cl bond angle. Cl-CO-Cl bond angle can be 90 degree. The Cl-CO-Cl bond angle can be 180 degree. We will mark the option second. The possible bond angles are 90 and 180 degree. Now let's move to the next question. Decreasing order of stability of the following compounds. Again, we can consider this as a question from GOC, stability of the carbocations. We'll compare the stability of the carbocations from resonance and other effects. It is clear that if you look at the B option, the lone pair of nitrogen takes part in conjugation with the pi bond, which is in conjugation with the positive charge. The lone pair plus M stabilizes the carbocation. If you look at the D option, in the D option also, the lone pair of nitrogen is stabilizing the positive charge. So in both B and D, the plus M of lone pair of nitrogen stabilizes the positive charge. So both B and D will be more stable than A and C. In A and C, we can see that the lone pair of nitrogen is not in conjugation with the positive charge. Lone pair of nitrogen cannot take part in conjugation with the positive charge. Although it is in conjugation with the pi bond in C, the lone pair cannot take part in any conjugation in A. Therefore, we'll say that B and D are more stable. Between B and D, we can see that B and D, in B there is more resonance, extended conjugation. Lone pair sigma pi, sigma pi, sigma positive. There is extended conjugation on the positive charge. Therefore, B becomes more stable than D. B is more stable than D and B is the most stable. The most appropriate option will mark the third option. Understood? Now let's move to the next question. Which of the following is the correct order of SN1 reaction? We can consider this as a question from alkyl halides chapter, alkyl and aryl halides chapter, but it is also based on SN1 reaction reactivity based on stability of carbocation. We can say that rate of SN1 proportional to stability of carbocation. So effectively, this question becomes a question of carbocation stability. Now we can form the carbocations. All of these options will form benzylic carbocation. We can get a plus charge here. Chlorine will ionize, we'll get a benzylic carbocation, and we'll compare the effect of the substituents here. NH2 is a plus M group, will stabilize the carbocation. OMe is a plus M group, will stabilize the carbocation. NO2 is a minus M group, will decrease the stability of carbocation. Between NH2 and OMe, NH2 is a stronger plus M group. It will result in greater stability. The most stable carbocation is formed by C. C will be the most reactive. Order of reactivity will be C greater than B. greater than, between A and D, A will become less reactive because of minus M effect. Minus M effect will decrease the stability of carbocation. Order becomes C greater than B, greater than D, greater than A. C, B, D, A. Which option will mark? Will mark the second option, C, B, D, A. I hope it's clear to everyone. Now let's move to the next question. Next question from electrochemistry regarding lead storage battery. Not exactly from electrochemistry. We have to find the temperature at which liquid will freeze. The concentration of H2SO4 is given. It's basically a question from the chapter solutions and colligative properties. The value of Van't Hoff factor is given. The value of the Kf is also given. We'll directly apply the formula delta Tf is equal to I into Kf into M. Value of I is given. I is 2.67. Value of Kf is given. Molar depression constant, it is 1.86. Value of molality. Molality, M is molality. Molality will find from the concentration in weight by weight. Weight by weight, 38% weight by weight H2SO4 means 38 gram H2SO4 in 100 gram solution. 38 grams in 100 gram solution means remaining 62 grams will be water. So 38 grams of H2SO4, moles will be 38 by 98 divided by mass of water will be 62 into 1000 will give us the value of molality. So this entire term will give us the value of molality of the solution. If we solve it, we'll get the value as around 31.06. So depression in freezing point has a value of 31.06. Therefore, the freezing point of this solution will be around minus 31. The solution will freeze most likely at minus 31 degrees Celsius. Correct answer will be the second option. A little bit of calculations involved. We need to calculate and little bit of time taking question. Not very straightforward, but still directly formula based question. The students are expected to solve this. We can consider this as a question of inorganic chemistry. KMnO4 is an oxidizing agent. It can act as an oxidizing agent in both acidic and neutral mediums. It oxidizes I minus in acidic and neutral medium to which forms? We know that I minus in acidic medium is oxidized to I2. In acidic medium, it will be oxidized to I2. In neutral and weakly alkaline solutions, I minus is oxidized to IO3 minus. So most likely answer will be I2 and IO3 minus. Respectively, we have to mark acidic and neutral medium, I2 and IO3 minus will mark the fourth option. Correct answer will be the fourth option. Let's move to the next question. Which of the following equation is correct? Again a question from inorganic chemistry, S block chapter, decomposition of nitrates. Actually, these are all thermal decomposition of nitrates. Lithium shows properties similar to magnesium. Lithium shows diagonal relationship. Lithium nitrate decomposition is different from other alkali metal nitrates. Normally, alkali metal nitrates give this decomposition where alkali metal nitrates decompose to give nitrite and oxygen, but this reaction is shown by sodium, potassium, rubidium and cesium, not given by lithium. Lithium nitrates decomposes similar to magnesium nitrate. It decomposes to give oxide, NO2 and O2. NO2 gas is evolved on decomposition of lithium nitrate. This reaction is similar to decomposition of magnesium nitrate. Other alkali metal nitrates will decompose as per the second reaction. Lithium nitrate will decompose to form lithium oxide, NO2 and O2. Now let's move to the next question. Now this is again a question from coordination chemistry where we have to match the complexes given in list 1 with the correct hybridizations given in the list 2. NiCO whole 4, nickel in 0 oxidation state. It will have a D10 configuration, D subshell is fully filled. Only possible hybridization for coordination number 4 is sp3. NiCO whole 4 is sp3. We'll write the hybridization of NiCO whole 4. NiCO whole 4 is sp3. NiCN whole 4 2 minus. This is nickel 2 plus, nickel 2 plus, nickel in D8 configuration. Cyanide is a strong ligand. It will favor formation of a square planar complex. Square planar complex hybridization will be DsP2. Then next CuH2O whole 6 2 plus Copper 2 plus is in D9 configuration. D9 configuration, whether the ligand is a strong ligand or a weak ligand, octahedral complexes will always be outer orbital complexes. Hybridization will be sp3d2. And FeCN whole 6 4 minus Fe2 plus ion, Fe2 plus ion 3d6 configuration. Cyanide is a strong ligand. Strong ligand will favor formation of inner orbital complex in d6 configuration. FeCN whole 6 octahedral complex, hybridization will be d2sp3. So correct match will be A matches with 1, A matches with 1, B matches with dsp2, B matches with 4, C matches with sp3d2, C matches with 2, and D matches with d2sp3, D matches with 3. 1 4 2 3, 1 4 2 3 will mark the first option. Understood? Let's move to the next question. Now this is a question from chemistry in everyday life regarding antihistamines, anti-allergics and antacids. Antihistamines prevent the secretion of acid in stomach. This is the statement 1. Normally, the commonly used antihistamines, Seldane, Cimetep, they work on receptors present in the respiratory system and they are used as anti-allergics and they have no action on the secretion of acid in stomach. So this statement is not correct. Antihistamines, normally they do not have any action on the secretion of acid in the stomach. They work on receptors present in the bronchi and the respiratory system. Now talking about the statement 2. Antihistamines are mostly anti-allergics. Now talking about statement 2, anti-allergics and antacids. Anti-allergics work on receptors present in the respiratory system, present in the bronchi. Antacid work on the receptors present in the digestive system, present in the gut, present in the stomach. They do not work on the same receptor. So this statement is also wrong. So both are incorrect. Correct answer will be the fourth option. This question based on chemistry in everyday life. I will say that this is an easier question where the question is not based on the structures, complicated structures. It's a conceptual question based on the concepts given in the chapter chemistry in everyday life. Now let's move to the next question. Question based on metallurgy, conceptual question. Hall-Héroult process. Hall-Héroult process is the electrolytic reduction of alumina, molten alumina. Alumina has very high melting point. To reduce the melting point, we often mix fluorspar and chloride. So mixing of CaF2 and Na3AlF6 decreases the melting point of alumina, decreases the melting point of Al2O3. Statement 1 is very much correct. And looking at the statement 2, it's talking about electrolytic refining. Electrolytic refining of metals, normally at anode we take the impure metal, at cathode pure metal is obtained. So this statement is wrong. They are saying that anode is pure and cathode is impure. This statement is wrong. Normally impure metal is taken at the anode, pure metal gets deposited at cathode. So we'll say that statement 1 is true and statement 2 is false. Statement 1 is correct, statement 2 is incorrect. Correct answer will be the second option. Understood? Now, next question. Let's move to the next question. Nessler's reagent. Where do we use Nessler's reagent? It's an important laboratory reagent often used in detection of ammonia and ammonium ions, and it is formed by mixing excess of Ki2 HgI2. The reagent is K2HgI4. Actually, the reagent is alkaline K2HgI4. The most appropriate option will mark the first option. It gives a brown coloration in presence of ammonia or ammonium ions. Now, boric acid and BF3, again a question from inorganic chemistry P block we can say, or we can also call it as a question from chemical bonding. Boric acid BOH whole thrice. Boric acid BOH whole thrice has a hexagonal layered structure in which boric acid molecules are interlinked by hydrogen bonds, because of which boric acid exists as a solid, whereas BF3 cannot form hydrogen bonds. BF3 exists as a gas. So most appropriate answer will be hydrogen bonding is present in boric acid. There is no hydrogen bonding present in BF3. Therefore, BF3 will exist as a gas, will have lower melting point, boiling point. Boric acid will have higher melting points and boiling points. Fine. Moving on to the next question. Now, this is a question from electrochemistry. Electrochemistry, little bit of calculations involved, not very difficult calculations. calculation of E cell. We have to calculate the E cell. We'll apply the Nernst equation. We apply the Nernst equation. We write E is equal to E naught minus 2.303 RT by F, 0.06 by N. If you write the cell reaction for this, at anode oxidation will take place, at cathode reduction will take place. The cell reaction can be written as X plus Y2 plus, giving X2 plus Y. This is oxidation, anode, this is reduction, cathode. Now, the Nernst equation is E is equal to E naught minus 0.06 by N. It's a gain and loss of 2 electrons. We'll say that value of N is 2. So 0.06 by 2 log of products by reactants. Products, we have X2 plus, concentration of X2 plus upon concentration of Y2 plus. We'll just put the values. How to calculate E naught? E naught will be E naught cathode minus E naught anode. Cathode is Y and anode is X. We'll write E naught is equal to E naught of cathode minus E naught of anode. Cathode is Y and anode is X. Both are reduction potentials. It will be 0.34 minus of minus 0.76. We can also guess the electrodes here. 0.34 is the copper electrode, 0.76 is the zinc electrode. This comes out to be 1.1 volt. Now we'll put the value of E naught in the above expression in the Nernst equation. Putting the value of E naught, we'll get, let me solve it here. We'll get E is equal to E naught value 1.10 minus 0.06 by 2, we'll get it as 0.03 log of products by reactants, concentration of X2 plus upon Y2 plus. What is the X2 plus concentration? 10 to the power minus 3. What is the Y2 plus concentration? Y2 plus concentration is 10 to the power minus 2. If we solve it, this comes out to be 10 to the power minus 1. Log of 10 to the power minus 1 will be minus 1, 1.10 minus 0.03 into minus 1. This will be equal to 1.10. 1 minute. We can write 1.10 plus 0.03 is equal to 1.13 volts. Now we have to calculate if E cell is equal to T, this is equal to T. Find the value of 5T. So 5T is equal to 5.65. The nearest integer will be 6. Nearest integer will be 6. Find 5T. The nearest integer is 6. So answer to this question will be 6. It's a numerical value type question. We have to mark the correct answer. The correct answer for this question will be 6. Little bit of calculations involved. Two calculations involved. One calculation of E naught based on the E naught cathode and E naught anode, and then applying the Nernst equation to find the value of E, and 5 times the value of E we have to find, which is approximately 6. Now moving on to the next question. Find the number of formula units of FeO per unit cell, round off to the nearest integer. This is a question from solid state. Density is given, edge length of the unit cell is given, and the Avogadro's number is given. The formula that we use here is density is equal to m into z by a cube into Na. M into z by a cube into Na. What we have to find? The number of formula units of FeO per unit cell. That means we have to find the value of z. So z is to be calculated. So z is equal to, we'll get density into a cube into Na upon the molar mass. Let us put the values. Density given as 4 grams per centimeter cube. We'll use proper units. Density grams per centimeter cube. We'll take the value of A also. A is given as 5 angstrom. we'll take it in centimeters. 5 into 10 to the power minus 8. 1 angstrom is 10 to the power minus 8 centimeters. Into Avogadro's number, 6 into 10 to the power 23 divided by the molar mass, that is equal to 56 plus 16. 56 plus 16, we'll write it as 72. We'll write the molar mass of FeO as 72. Now we'll just need to solve this. This will be 4 into 5 cube. 5 cube is 125. 4 into 125 into 6. And then this is 10 to the power minus 24 and this is 10 to the power 23. This becomes 10 to the power minus 1 upon 72. This is 12. 1 by 12, 4 into 125, we can write it as 500. Into 10 to the power minus 1 divided by 12, which is equal to 50 by 12, which is equal to 4. Approximately 4.2. The nearest integer will be 4. So, we will mark the answer for this question as 4. The number of formula units of FeO per unit cell will be 4. So, little bit of calculations involved. Just that we'll write all the entire expression and do the calculations. We'll cut the expression and simplify the expression. 500 into 10 to the power minus 1 is 50. 50 by 12 is approximately 4. Now moving on to the next question. This is a question from chemical kinetics. The time required for 60% completion of reaction is given and we have to calculate the time required for 90% completion of the reaction. The formula that we use here is time required for X% completion is equal to 1 by K ln 100 upon 100 minus X. We'll use this formula to establish a ratio between T 90% and T 60%. T 90% upon T 60%. When you find out this ratio, the constant, rate constant will be cancelled out. 1 by K will be cancelled out. We'll get ln 100 upon 100 minus 90, that is 10, upon ln 100 upon 100 minus 60, that is 40. So, this comes out to be equal to ln 10 upon ln 10 by 4. The ratio of ln can be taken as equal to ratio of log. This is equal to log 10 upon log 10 by 4. Log 10 is equal to 1. Log 10 by 4 can be written as log 10 minus log 4. Log 10 is again 1. Log 4 is 0.6 given in the question. Log 4 is given as 0.6. So, this comes out to be 1 by 0.4, that is equal to 10 by 4. Now, from here we will get T 90% is equal to T 60% into 10 by 4. What is the value of T 60%? Given in the question, T 60% is 540. So, we will put 540 into 10 by 4. This comes out to be, we will cancel this from 4, 135 into 10 is equal to 1350 seconds, which is equal to 1.35 into 10 to the power 3. Now, the question asks the value of time required for 90% completion is 1.35 into 10 to the power x. Find x. So, x value will be equal to 3. So, answer for this question will be 3. Understood? So, little bit of calculations involved, not a very straightforward question, but if you know this formula, we can simply put the values and solve it. We will get the value of x as equal to 3. Now, moving on to the next question. Now, this is a question from thermodynamics regarding an adiabatic process. An easy question. We know that in an adiabatic process, we have delta U is equal to W is equal to NCV delta T. W is given, work done is given as 3 kilojoule. 3 kilojoule is 3000 joules. Value of number of moles 1. Value of CV is given as 20. We will calculate the value of delta T here. Delta T comes out to be 150. Delta T comes out to be 150. Now T1 is 27 degrees Celsius. T2 will be 150 plus 27, that is equal to 177 degrees Celsius. We have to find the value of T2 in degrees Celsius. The answer will be 177. The correct answer for this question will be 177. Straightforward question, just equating the expression of W to NCV delta T, we can calculate the value of delta T as 150. Initial temperature is 27 degrees Celsius, final temperature will be 177 degrees Celsius. Fine. Now, let us move on to the next question. Next question regarding volume strength of H2O2 is from the hydrogen chapter. Volume strength is the volume of oxygen produced at STP on complete decomposition of 1 liter H2O2 solution. The volume strength can be related to molarity as we can write volume strength is equal to molarity into 11.35. From this, we will first calculate the value of molarity of the solution. Molarity comes out to be equal to volume strength by 11.35. Volume strength is given as 60. 60 by 11.35. This is the concentration in moles per liter. This is the strength of H2O2 solution in moles per liter. But we have to find out the concentration or the strength in grams per liter. Moles per liter, we can convert this into grams per liter. We can write concentration is equal to 60 by 11.35 moles per liter. To convert moles per liter into grams per liter, we will multiply by molecular mass of H2O2. Molecular mass of H2O2 is 34. So, this into 34, we will get the value in grams per liter. If you solve it, this will be around 179.7, which is approximately equal to 180. The correct answer will mark, the nearest integer will mark for this question will be 180. Fine. This completes our discussion. All the memory based questions we have solved it here. Hope this session is useful and you have understood the solution to each and every of these questions. Thank you.